in this game, like reading the documentation and not knowing what you're doing and figuring out what you're doing is a big part of it. And sometimes it's easy to think Dr. Penland will figure it out for me. I do want to be a helpful resource, but there's a sense in which maybe it helps sometimes to start with less of a certain idea and go through the experience of it's like doing basketball practice, but no one ever misses a shot, so you never work on rebounding. It's not realistic. You want to get comfortable with being uncomfortable, in my opinion. So this week we're going to actually dive in. We're going to do two things. We're going to do some actual exploratory data analysis on the Titanic data set. And I've given you exploratory data analysis involves thinking of questions that you might want to know the answer to and then figuring out. It's like having a conversation with the data. It's like getting to know the data. When you meet a new data set, you want to spend some time thinking about, what do I want to know? Our goal here is to understand what factors contributed to survival on the Titanic. So we're going to be viewing everything through that lens. So what we're going to be doing in the early part of this notebook, you'll need to start with your import statement. Make sure that you import pandas, seaborn, and then you'll need to figure out how to import a decision tree classifier, which will involve doing your browser of choice. A couple of basic commands that you can use. The first is columns. Columns is not a function, it's actually an attribute. And the first thing you want to do is read the data into some kind of data frame. So Titanic. Another tool that's useful sometimes is there's a command called describe that's associated with data frames. We used head before. Head shows the first 5. We're getting to know this data. It's good to know what data do we have access to. So we could look at Titanic df.head, which will show us the first 5 entries of each column. It can also be helpful to look at Titanic df.scribe, which is a function that gives you just a little bit more information about the variable types. So after you've looked at the columns, before you look at the missing values, it might be good to create a new cell and do Titanic df.head, and you can see what some example entries are. And we can also do Titanic df.describe, which gives us sort of more information. Another thing that can be useful is dtypes, in addition to columns. Dtypes tells you what the type of each column is to the best that it can determine. This is really helpful for knowing if something could be a number or if it's supposed to be a string. So the next thing to do, you can use .isna, and it will give you yes or no for each entry, whether or not that entry is missing, which means it's going to be a 0 or a 1. That's not terribly helpful. So instead, you can chain isna with .sum, and if you do that, it adds up all of the 1s. And so this is 2 different commands. This is a command that gives 1 if data is missing, and 0 if it's not. But then we can't eyeball it. I mean, we don't want to look at it and do it by hand. So we're going to take the output of that, and we're going to run it through this .sum command, which adds up all the entries in the column. And so that'll tell us the total number of missing entries. There are a ton of missing cabin entries. That's a lot. And cabin, if you look at it, cabin is actually very unique. It's the room they were staying in. So I think it makes sense to drop that column. What I find is that often looking at the examples at the bottom is more helpful than actually reading through the list of keyword arguments at the top, because they realize that it's difficult at times for people to go through all of that. So at the bottom, they put lots of examples that might map to specific situations that you want to do. Let's see if we can find the one that would involve dropping this column called cabin from our data set.